Hello, everyone, and thank you for joining us for today's webinar. ezCater accomplishes early prediction of lifetime value with Stitch and RapidMiner. I'm Haley Matisa with RapidMiner, and I'll be your moderator for today's session. I'm joined today by Jeff Dwyer, Software Engineering Manager at ezCater. Welcome, Jeff. I'm also joined today by Than Adams, Business Operations Manager at Stitch Data. Welcome, Than. Jeff will get started in just a few minutes, but first, a few quick housekeeping items for those on the line. Today's webinar is being recorded, and you'll receive a link to the on-demand version via email within 1 to 2 business days. You're free to share that link with colleagues who are not able to attend today's live session. Second, if you have any trouble with audio or video today, your best bet is to try logging out and logging back in, which should resolve the issue in most cases. Finally, we'll have a Q&A session at the end of today's presentation. Please feel free to ask questions at any time via the questions panel on the right-hand side of your screen. We'll leave time at the end to get to everyone's questions. So I'll now go ahead and pass it over to Jeff.
All right, great. Thanks everyone for coming. To start off, I just wanted to ask a quick poll to get a little bit of a read on what everyone is most interested in learning about today. So I'm going to launch that now. Great. So yeah, if you wouldn't mind just filling that out, I would love to hear whether people are most interested in the sort of a couple different things we're going to talk about. One is how we integrate our data warehouse, how we get all the data into our data warehouse via Stitch. One is the machine learning techniques that we are using. One is sort of the business case around ezCater's LTV prediction story, and the other is our usage of RapidMiner. So excellent. All right. Thank you all for voting. 70% of you have voted. This is so exciting. Fabulous. All right. And the winner with 81% of precincts voting is machine learning techniques and the ezCater LTV story. So great. That's super useful. Thank you for doing that. I'm going to close that up. Okay. So all right, so let's take a look at the agenda today. So first off, I want to explain sort of how we got here and why ezCater, why we were interested in this in the first place. It all began with the promotion. That led us to trying to figure out, how do we estimate lifetime value? What is how do other people do that? What is sort of the best practices in this area? So we'll do a summary of my Googling. We're going to take a little aside to do some definition of terms, because what we actually predict is year one revenue. And we'll talk about how that is different from long-term value or customer lifetime value. Then we're going to talk about how we collect all of the data. We'll turn it over to Stitch to explain a little bit about their product and how we use that to collect a bunch of data. And then we'll get into what we actually did with that data, training the model. A lot of lessons around what we learned about machine learning. This was sort of our first machine learning project at ezCater. The limits of what we sort of found with the initial approaches and how we ended up using RapidMiner, what techniques we used within RapidMiner, and how that worked out for us. Okay, so first, a bit about ezCater. We are an online marketplace for business and corporate catering. So it's a little bit like Grubhub, but for catering. If I didn't really realize before I started working at ezCater why that was such a big deal, why that needed to be different than Grubhub, it turns out that there's sort of nothing scarier in the world than having told maybe 100 people in your office. You're an office manager, and you have told your entire office that there will be food for lunch on Thursday, and then the food is not there. And that is kind of the scariest thing in the entire world because you have a lot of very, hangry people. ezCater exists to sort of fill that gap. We make sure that the food will really get there. We call the caterer. We connect in between there. In crazy cases, we'll be like, look, I don't think the food's going to get there. We will just order pizzas on your behalf so that at least there is food there and we can sort of save your bacon. That's been pretty popular. So we've raised $35 million last year and are growing between 2 and 3x year over year for the past couple of years. And yes, we are hiring. Who am I? I'm a software engineering manager. I work on growth, analytics, and warehouse stuff at ezCater. It is important to say that, yeah, I am not a machine learning expert. If I watched the Coursera, I read the book, but I am sort of, that's about it. Do not take anything I say as gospel. I'm definitely a noob here. You can follow me on Twitter at jdwyer, and there's also a number of blog posts about this and sort of similar issues or similar topics on the ezCater software engineering blog, engineering.ezcater.com. Okay, so a little bit about the business, which is to sort of set up the problem here. We're part marketplace, but we are also sort of part SaaS, right? Software as a service. Customers really love us. They keep using us. This good retention makes the unit economics of our business more like a SaaS and less like just an e-commerce shop. The principal difference there is that an e-commerce shop, if they want to sell you, maybe a pair of shoes, if they're going to sell you shoes for $100, they need to make their money back on that purchase. They sort of can't spend more on that customer than they're going to make back in profit on that sale. Whereas software as a service, something like a Salesforce.com, they're going to have you for months and months and months for years, right? So they can actually spend a bunch more upfront to get a customer because they know that they're going to stay around. But the corollary to that is that the customer quality is really kind of even more important than the number of new customers. So in a SaaS business, you have been acquiring customers on average. They're worth about X. And somebody, clever suggests a promotion. Hey, how about we say $5 off your first order? That'll get more people through the door. You release it, right? Boom, conversion rates increase, and the number of new customers increase, which is, yay. Because, $5 off, numbers always go up. But then someone asks that pernicious question, right? Are we sure that we're still getting good customers? Put simply, is the promotion actually worth it? One disclaimer before we get into numbers, all of the numbers in this webinar are made up. They are either 10 times higher or 10 times lower than all of our actual numbers, so it's not to share all of the details. So a little SaaS unit economics primer. This is the sort of the unit economics model of most SaaS businesses. We're going to spend a lot of money up front, and then we're going to get it paid back month after month after month, right? Then this is the cumulative cash flow here. You can see, right, we're going to start off in the hole, and then it's going to come back. And at month 13, that's our sort of our payback period. And this is a good, happy SaaS operating model here. Now, as you can kind of see, it all relies on the fact that people come back month after month and keep paying you money. If you end up getting customers that are bad, you can end up burning a ton of money very quickly, right? If you spend $6,000 on people and then they quit after 1 month, you're just in the hole. So again, the customer quality and understanding your customer quality is like super important for any SaaS business. Retention is king. Retention is the probability that people leave on a monthly or yearly basis, whatever you're looking at. Okay, and retention is LTV. That's what we're really looking for. We're looking for the long-term value of these customers, and LTV needs to be greater than the amount we pay for the customers. Otherwise, you're truly losing money. Okay, so you would think that with such an important number, there would be a whole bunch of things on the internet about how to estimate LTV. But most of certainly what I found is sort of stuff like this. So this is, well, this is really a one-time calculation. Let's take all of our customers. Let's figure out their average revenue per user. People call it the ARPU. So we take how much revenue we make, how many users were there. We call that our ARPU. That's how average revenue per user. We pick a churn metric, and then we come up with an LTV, right? This is totally correct and is totally not actionable for the use case that we're talking about today, right? We want to know whether or not that the promotion we just released is giving us different customers. And there's nothing about this calculation that is going to tell us that, right? If this calculation says, hey, we've had 1,000 users and we average out, we get an ARPU of $1,000. if someone comes up with an idea of like, hey, let's give everybody a $500 iPad when they sign up, we'll still make $500, right? This is sort of patently absurd. Obviously, customer quality is going to matter. If you give people a $500 iPad without asking for anything, you're going to get a whole bunch of people that just want an iPad, right? You can't just rely on your historical ARPU. Okay, so it all boils down to the question of, given just a small number of days of customer data, how can I predict their year one revenue, and how accurate can I be with that? Okay. So this is the quick aside into naming things, because I'm going to switch here from LTV to Y1R. Turns out LTV, lifetime value, or customer lifetime value, are loaded terms. They imply that you sort of have an idea for the multi-year retention profile of your customer, right? The long-term value, you might have a customer for 7 years. Like, what is do you really have enough people to predict what the drop-off rate is going to be in their 6th year? Probably not. Also, a bunch of things like the weighted cost of capital, which means dollars in the future are worth less than dollars today. When you actually use the words LTV, you're sort of implying that you know something about these two factors, which you may or may not, and it gets pretty confusing pretty quickly when you try and understand that. What we have simplified for at ezCater is we say year one revenue. Because year one revenue is pretty clear. It's how much revenue somebody made in a year. It doesn't have any sort of weird numbers associated with the weighted cost of capital, that kind of stuff. And most importantly, it's just as actionable, right? People that are good in their first year for us are good people, and if we see this number going down, that is absolutely indicative that there's a problem going forward. So no arguing about definitions, and it's kind of extensible. So we have extended this Y1R pattern to be Y1B is how many bookings we have in a year. EY1R is the estimated year one revenue. D180R, would be the day 180 revenue. This has been super useful so that when we're actually talking about, whenever we're having conversations, it's super clear that we can compare this number against this number and they should be equal, and we're not just sort of someone's using a different weighted cost of capital versus someone else, and that's why you're getting different numbers. Okay, data. We are going to need some in order to predict this thing. Velociraptor says, I will need data if I am to learn. So what kind of data are we going to have after a few days of a new customer on the ezCater website, right? What we're going to have is we're going to know how, their order size. We're going to have what day of the week they made their orders for. We're going to have, food type. Was it Mexican food, barbecue food? We're going to have, was this morning catering, midday catering, evening catering? How many people was it for? What state or location where they are? And then from the training set, we're going to have how much actual year one revenue was there. And then one important feature here also, right, is how many orders did they make in the first X days, right? So that kind of stuff. Then you're going to have your new data, right? And this is the stuff that's going to come in, and you're going to we want to predict that column where there's the holes, right? This is, when you have data like this is what machine learning loves, and this is what we need to feed it. But of course, some of this stuff and some of the most interesting stuff, because I showed like 6 features there, we have a bunch of other features. How many times did they click on the emails? How many page views did they have? Did they ever view this page view? What advertising campaign did they ever contact us? Did a salesperson ever contact them? This is in our HubSpot, this is in our CRM, this is in our AdWords account, all this various stuff. It's not in our data warehouse. So this is where I turn it over to Stitch, because Stitch is what helps us get all of this data into our warehouse.
Thanks, Jeff. All right, so first off, what is Stitch? Well, it's a SaaS platform designed to consolidate data from a variety of sources and stream it to a centralized data warehouse. So what's it like getting started with Stitch? Well, getting set up takes 3 simple steps, and it's entirely self-serve. And we see a lot of our customers start streaming data in less than 15 minutes. In terms of pricing, it's really straightforward. We have a free plan for smaller data volumes, and paid plans start at $100 per month. There's no commitment required, and you can connect as many data sources as you want with no increase in cost. Stitch's integrations are built on an open source framework called Singer. Stitch connects to over 70 integrations natively, and these integrations are to databases, ad networks, CRMs, email service providers, payment processors, and so on. But we found that this covers most of the data sources for the majority of our clients. But it's also common that a client will find themselves working with a less popular tool. And in that scenario, there are 3 ways to get an integration added to Stitch. You could leverage your own engineering resources to build it. You could work with one of the service integrators that Stitch partners with, or just bundle the development into your Stitch contract. Singer allows Stitch to be an extensible platform that can support just about any use case for data. Stitch is also a powerful tool for the enterprise, with features like HIPAA compliance, solid security, and integration with enterprise tools like data warehouses and data lakes. Partnering with ezCater has been awesome. And if you want to know more about our partnership, you can read about it in the Stitch ezCater case study. Now I'll pass it back to Jeff, who's going to talk about how he used the data.
Awesome. Great. So yeah, I'd say everything he just said was true. We were probably up and running in a matter of 15 minutes, connecting to various ad sources like HubSpot or SendGrid and piping those into our data warehouse. The integrations that are particularly useful for us are things like the ad networks, Bing, Facebook ads, the Google ads, sort of SendGrid for getting email opens and clicks, that kind of thing. And then the 2 particularly interesting ones here were AppsFlyer and HubSpot. AppsFlyer is something that when you buy mobile ads, it helps connect mobile ads to app installs. It sort of does a little bit of magic there. There was no integration for that, so we were looking at building that ourselves. And we were going to need to write a bunch of code to hit the AppsFlyer APIs, remember where you sort of put a high watermark for how much data we captured out of those things. And guess what? That's exactly what Singer does, right? So we wrote it as an AppsFlyer tap. We wrote it open source, and then it got integrated in by Stitch. And so now we contributed that basically to the community. Now you don't need to do that. The HubSpot integration already existed, but we needed some special things. There were some fields and various things like that we needed, and so we were able to do multiple pull requests into an open source repository and have that integrated as well. I think one of the dirty secrets about all of these data integrators, or I don't know how dirty, but is that they really don't know the data sources as well as you, right? Stitch needs to understand 150, 200 different integrations. And the fact of the matter is there are intricacies in all of these things. So the HubSpot data, like, oh, well, what does this field really mean? And what this field is actually super important. It's going to be the end users, i.e. you, that actually knows those things. So being able to look at the code and understand what's happening and add that column is really pretty important. And so we feel like we're not nearly as locked in as we would be with some other solution where we didn't have the power to really see what the heck is going on there. Okay, so we've got all the data in, and it's sort of time to let the machines learn. As I said, I'm not a machine learning expert, but I did follow the advice when you're starting. Always let's do some simple regressions first. Reminder, this is what our data looks like. So we've got, day of week, food type, head count, and the actual Y1R. I want to be clear, there was no easy solution here. This is a really simple feature. How many orders did they make in their first 30 days on the x-axis, and on the y-axis is how much revenue they had in their first year. So there is no like magic bullet. This is not, there was no magic bullet. There was no super simple like, oh, it's pretty easy. Turns out some people, and what I think the intuition for this makes sense. Someone might order catering once a month, and you do 12 orders a year, you're a great customer, but you're not going to be, you're only going to see one order a month, right? So they're going to not look very different at a naive level from someone who orders catering once and never orders it again. So we started off with something, there's this thing called Kaggle, which is super useful. It's this competition where you can sort of bundle, they will help you bundle up all of your data, and then you send it, you put it up, and then as competition, you get lots of people to sort of compete to try and get the best results on your data. But then there's just a ton of data about people trying different approaches. One thing that we saw on there was this thing called Vopol-Wabbit, which is a very funny named solver, out-of-core learning algorithm. It does linear logistic gradient descent. Gradient descent overall is sort of putting all your features into, you probably all know more about gradient descent than I, so I won't try and explain it too much, but it does have a gorgeous picture, which is really why I put that there. So what Vopol-Wabbit looks like really is we took our features and then it has a nice readable input format. So you sort of do some code to output something where you can see that event day of week is feature B, event local time is feature C. This is a much longer line that I cut off. And then we're trying to predict the value 40. So it has really readable input format. It was super fast. We could do 500,000 records in under a minute, and it was blazing. And it had a bunch of built-in protection against overfitting, which was something I was worried about. Sort of being a neophyte, I didn't want to get something that was super overfit. But the cons were, the analysis is totally do it yourself. So you've got a lot of R or Python ahead of you to figure out what you've actually done. Simple things like viewing the feature weightings on your regression was totally wonky, and was, some other command line flag to output some weird file. If you were going to build a pipeline to query your database, build a model, run new data, put it back to your database, that's all going to be do it yourself too. Vopol-Wabbit does one thing, it does it well, but it does one thing. And overall, then the final result was that regression for us was not a fabulous fit for this problem. This is sort of what we would get out of Vopol-Wabbit eventually. We would get, weightings for all of the various features. So positive and negative weightings for like what day of week the event was, positive, negative values for what type of food the person had ordered and that. But it turns out that regression, this showed as a square. This was supposed to be a unhappy face. So regression and codependence of variables didn't work out great. I think essentially my understanding of the problem is that when we tried to do regression on this fairly tricky problem, we would end up in cases where things like people that order on the weekends are worse. If you order catering for Saturday, it's sort of likely that you're not a business case and that's not as good. Also, people that make fewer orders are worse, which is sort of obvious. But there are these dependent cases where it turns out if you actually make a bunch of orders, and if your first order was on the weekend, it actually sort of doesn't matter. So when we would get these sort of important features like that, weekend orders are bad, but because of those kind of the limits of a naive regression, those would make these people that would really underweight people that had made a number of orders. So, and the problem was that was sort of like one codependent issue that we found looking at the data. And I think the problem was we were pretty worried that there were like 100 other ones that we were just in. There was a lot of like we moved the features this way, we moved the features that way. I was really starting to get the feeling that like we didn't really know what we were doing, and we were likely to the results were just not that great. So the next step is like, okay, well maybe regression is not going to be able to solve this problem. But then you end up in this as a neophyte, you end up in this sort of like, well, what should we try? And there is no end of things we could try, right? There are gradient boosted trees, random forests, clustering, neural nets. I mean, there are so many other choices. I felt like this dog looking at the sort of the infinite menu of machine learning techniques. And the challenge at that point is that you really have two choices. One is similar to Vopol-Wabbit, which would do a couple of these techniques, but it wouldn't do gradient boosted trees, which sounded pretty interesting. So now you're going to install some other library and learn all of the intricacies of it, or you can sort of go to Python and ezCater or R, and for every one of those techniques that I tried in Python or scikit or doing it with some standalone library. It's like you start the learning curve back at 0, and you have to learn all of the intricacies of that tool. You have to reformat your data, and you still don't get a ton of help on the analysis side. So the other choice was to see whether or not there's something for one of these machine learning companies, and that's what I did. So I'm going to turn it over here to RapidMiner.
Hi, my name's Ryan Johansson, and I'm part of the customer success team here at RapidMiner. One thing that was great that Jeff alluded to is that he's not a machine learning expert. And the good thing is you don't need to be a machine learning expert to use RapidMiner. Obviously, it doesn't hurt. But what we do is really lower the barrier for machine learning for people that are experts in their domain and business like Jeff is. So the cool part about my job is you get to work with a lot of different people like Jeff, but with many different types of companies and use cases, and my team helps customers helps them leverage machine learning to increase their revenue, reduce costs, or avoid risk. So people come to us with an idea. We get to work together over a few sessions, and I get to experience that first aha moment of, oh my God, it really works. So Jeff will give kind of a rundown of RapidMiner, but just a quick overview. We're a platform for real data science that unifies data prep, machine learning, and model deployment in a single interface. So people can use, well, here's a picture of someone like Jeff using RapidMiner. As you can see, it's a visual interface that allows for people to create, share, and easily explain their workflows within their company. So just for the product side, we have 3 main products. So RapidMiner Studio is the primary platform that allows you to design your analytic workflows, quickly prototype your best model, and validate the results. Servers for collaborating with your team, increasing your compute power on large data sets, and scheduling processes. And RapidMiner Redupe is a code optional way to use some of your machine learning on Hadoop or Spark in a big data environment. So if any of this seems like a project you'd like to leverage machine learning with in your business, we'd be happy to hear from you.
Cool. So so this is what it looked like when I logged into RapidMiner. And what I thought was super awesome was I would sort of pretty quickly I was able to get the same CSV that I had into RapidMiner and do a simple regression. But then rather than when I wanted to try experiment with a bunch of different algorithms, gradient boosted trees, neural nets, deep learning, it was literally dragging and dropping this little purple line here from the training set through the model, through the algorithm and out to the model. And that was exactly how hard I had hoped that would be. A number of other things, like sort of the way I wanted to compare these things was by looking at the ROC curves of one algorithm versus another. I tried to set that up in R, and I ended up with incompatible libraries and installing other binaries and all of this stuff. That just worked. Again, in RapidMiner, you drag over the compare ROC tool, and then you plug a bunch of things into it. I like that better. A bunch of other sort of, it was nice to see that a bunch of other fancy stuff like optimizing the hyperparameters of your algorithms, grid evolutionary. This is all stuff I was sort of going to have to build myself or do a bunch of research on. Being able to drag those and drop those into my model was appealing. And mostly, I think it was just super compelling that there was a free trial. It took an hour or so to get my CSV to regression outputs, and it was super easy to explain the pipeline to new colleagues. So I just felt I had a bunch of confidence very quickly that, like, hey, this was sort of going to work. So that made me happy. So here's a little bit of we're going to take a quick look through what our pipeline actually looks like. We query Redshift right out of RapidMiner. Redshift is the data warehouse where all of our data is. So we have our SQL query right in here. We put that into a local store. We then pull that back out. And this is a picture of how you can sort of generate new attributes. So the example here is you want to try a new feature, and really quickly you can, like say weekday, right? So rather than giving the model Monday, Tuesday, Wednesday, Thursday, maybe you just want to have weekday yes or no. And so really easy to just generate new features on the fly in RapidMiner itself. And then this is an example of what our pipeline looked like. And there's a bunch of lines here, but it's also really easy to explain to somebody new on the team what the heck is happening here. You can see, well, we are splitting out our training set. We are selecting attributes out of that data. We are running cross-validation on it, and we apply it back to the data that was not in the training set. And then you can see we write a CSV and upload it to S3. Way easier to share this with a colleague of various levels of technical skill rather than sort of point them at a long Python script. And I really didn't feel so analysis support, just being able to easily check off different performance metrics was compelling. And I didn't feel like there was sort of a lack of detail. It wasn't the case where I had tried Amazon's machine learning before, and it felt like you put stuff in and something comes out, and that was it. There was sort of no knobs, no dials, no details about what happened, and it was very easy. But also, I had no idea what happened and no idea whether it was could be improved or where it had gone wrong. And RapidMiner didn't hide sort of the underlying details. And additionally, a bunch of nice things like a nice visual graphs of the gradient boosted trees we ended up with just work out of the box. And so the results. I should say one other thing that came with RapidMiner once we did sign up was that we did also do some consulting work with them, and then so one of the RapidMiner consultants was actually the person that suggested gradient boosted trees to us, which turned out to work really well for our use case. So here's a quick look at results. So this is the actual data. So this is weekly average year one revenue. And then we can see what happens with only 7 days of data. We were able to predict this yellow line here. So that's actually, you can see the R squared is not great. It was like 0.23, which is not great. That's a pretty tough thing to do with only 7 days of data. And so what we more would look at was the accuracy of predicting a good versus bad customer, and that was already up to 82%. So we were pretty happy with that. But then you can see as we give the algorithm more data, as we give it now 30 days of data, you can see that it becomes significantly more confident in its prediction that people are either good or bad. And you can see that when we get to 90 days, it really is right on there. We've got like R squares are in 0.7, accuracy of prediction is like 0.94. So we were quite happy with these results. And pulling us all the way back to the beginning, right? We started off with a promotion, right? And so when we had previously analyzed our promotions, we would look through the conversion rate, right? So you have, this is an experiment with the control arm in blue and then two different promotions in red and in green there. And these all had, the red had a much higher conversion rate. But so it looked like the winner, but then this is the estimated year one revenue on those people. And you can see that in this case, the green one is, absolutely dominant on the other two. And so just totally changing the metric. I mean, we just literally changed the metric that we try and base almost all of our decisions off overnight by having this, right? Because if you're just trying to look for new customers, that's just totally different than trying to look for new quality customers and having a reliable and metric of that. So overall, our top line company metrics, right? Before we would look at new customers per week, and now we look at new estimated year one revenue per week. And there's just a fundamental and huge difference between those two things that has been pretty transformative. So yeah, that's all I have, but I would love to get into some questions and some details. Let's connect, and yeah, let's do some questions.
Sounds good. So thanks, Jeff. Thanks, Ben and Ryan as well. And as a reminder to those on the line, we will be sending a recording of today's presentation within the next few days via email. So like Jeff said, now it's time to get everyone's questions. So I'll go ahead and look through the questions that are coming in now, and I'll go ahead and address those. So the first question here is for you, Jeff, and it's, how have you productionized the machine learning?
Sure. So what we are actually doing today is we are currently actually babysitting. We're actually running it through the desktop app. Because the smallest amount of data that we need that we're predicting on is typically has been the 7-day model. We need to do it about twice a week or something, and that has given our data analysis team sort of, as we grow our comfort level around it, it has been pretty nice to be able to look it through the entire time, because there's been a lot of focus on it. But we are currently now moving to running the same model, which sort of just works, and running that with, you can also package up your model and then run a Java jar pointed at the same model, and it will export. And what the process that we have set up pulls data from Redshift and then puts it into S3, and then we have another cron job which nightly takes the results out of S3 and puts it back into Redshift to sort of turn that into a loop.
Great, thanks. Another question here, this one's for you, Jeff. How challenging is it to format the data in order to get all of the data methods and models to run in RapidMiner?
It takes a little bit of RapidMiner UI work there's a little bit of learning there, although I would say that if you have a CSV, it sort of does a guess. It actually has some really nice tools. So you go into RapidMiner, you say import CSV, and it's going to bring things in, and then it's actually going to give you a really nice, it's going to sort of pretty much guess on all of the different columns that you've got for what type of data it should be, categorical, et cetera. And then it's actually it gives you like ranges, mins, maxes, and distributions, just some simple charting, but some useful charting so that you can see kind of to make sure that your data actually looks reasonable. And that took a little bit of RapidMiner specific learning, but honestly, if you've used software before, I mean, probably this is in the under 2 hours of clicking around.
Great, thanks. Next question here is, can you go into more detail on how Stitch grabs the data and then gets it into RapidMiner via, you mentioned Redshift? Yeah,
absolutely. So Redshift is a data warehouse product from Amazon, and it's a pretty standard data warehousing solution. What you do is Stitch. Stitch needs access to write data into your data warehouse. So you have to set that up, and they'll sort of support you. Maybe you have to open an IP or get SSH access, but one way or the other, Stitch needs to be able to write. Then you go into the Stitch UI, and you pick from, I don't know how many integrations, 100-something integrations, and it's you click on, say, Google Analytics, and then it takes you to your Google Analytics page. You OAuth in, and you say, yes, grant Stitch access to my Google Analytics account. And for most of the integrations, you're kind of done there. And then it says, cool, we're set up. And then there'll be like a little slider, sync data every half hour, sync data every 24 hours, et cetera. And Stitch, on your behalf, through your OAuth token, will go and pull all the data from AdWords or HubSpot or whatever it is and deposit it in your data warehouse. Then the next step is that RapidMiner is then connecting to that same warehouse sort of asynchronously from Stitch and is doing whatever with that data.
Great, thanks. This question's for you, Ryan, and it seems like we have one story here, but how do most people get started with RapidMiner? Is it similar to ezCater's story?
Yeah, so there's a lot of options to get going with. So all it is, it's free to download RapidMiner. So you go to rapidminer.com, install the software. You can be up and running within minutes. We offer a lot of guided workshops that can walk you through the process. There's over 300,000 users, so our community has put a lot of learning materials too. We have books, and my team helps our users get up and running as well. So lots of different options.
Yeah, one other thing about that is, so we had for various things we were trying to do, we had maybe 500,000 or 1 million data points or something. And then what RapidMiner would do in the free trial portion, it would say, hey, you're in the free trial, and it would subsample that down to something like 100,000 or something, but it would let you do everything just on a subset of your data, which I thought was a clever way to make you want to pay for it. You could prove that it was going to work, and then it was only going to get better if you actually paid some money. So that was you were able. It wasn't like there were just features you couldn't see or stuff that was totally locked, which was good.
Great, thanks. A question here for Stan. What does the data coming out of Stitch actually look like?
Great question. You pretty much get the raw data in your warehouse delivered by Stitch. Our philosophy is to do the minimal amount of transformations necessary to get the data where it needs to be. And we're sort of the philosophy that transformation is better and faster done once the data is delivered to the warehouse.
Great, thanks, Ben. Another person here is asking, and I believe this was during your part of the presentation, is where do we go ahead and download Stitch?
Another great question. Stitch actually runs completely in the cloud. So if you go to stitchdata.com, you can sign up for a free trial right away, and it's an unbounded trial, so you can sort of have full functionality, and you can move some data.
Great, thanks. Another question here, this one's for you, Jeff. Did you consider state as one of the features? And they're saying, would you consider external features like impact of other restaurants around?
Yeah, so we did look at state, and there are some other things. We also, coming out of the data warehouse, we would join it to other sorts of things. There are some open data sets where you can get like a metro region and various things like that, which is kind of useful. State can be a rough one, just as the actual features go. New York is a pretty weird and different place, right? Upstate New York and New York City is pretty darn different. So I think there are things that are, for a lot of cases, pretty likely better than state, which are sort of metro regions, DMAs or PMSAs, which are terms I was not familiar with, but which you can find from sort of open, public data sets online. They're kind of collections of zip codes that are in a metro region.
Great, thanks. So it looks like we're just about time here. So if we weren't able to address the question that you might have had here on the line, we'll make sure to follow up with you via email within the next few business days. So thanks again, Jeff. Thanks again, Ryan and Stan, for today's presentation. And we hope everyone has a great day.
Thank you.